All right, lesson 38 from Unit 9 is going to be doing population projections using matrices. Okay, so when we go to do population projections, what we're going to need are three different pieces of information. We're going to need to know what our initial population is, and the population is going to be broken down into groups like how old they are. Um, then the other two pieces that we need is what is their survival rate for each year or month or whatever the time frame happens to be, and then how many babies do they have. So we're gonna make this a little bit simplistic. We're gonna pretty much look at female population on this, because it does make a little bit of a difference. Um, Obviously, if you mix males and females in, that's going to change this slightly of how it's computed, but it's still going to be the same basic idea. All right, so a population matrix we're going to write as a row matrix going straight across. So you're going to have, sorry, so you're going to have, why is that not going? There we go. You're going to have your numbers going straight across here that are given to you into a matrix like that. Okay, so for instance, if we have these numbers here 5, 9, 13, 5, 0, and 0, those would be the numbers that I would put in here. All right, then we're going to create something that's called a Leslie matrix. And the Leslie matrix is going to be birth rates and survival rates combined together. So notice that you'll be given a chart here that's going to tell you, based on their age, how many births they have by proportion, and then how many, not of the births that survive, but that age that survives. Okay, so if you're 3 years old in this one, you have an 80% chance of surviving to the next year. All right, so Leslie matrix works like this. So it is going to be a square matrix, meaning you're going to have the same number of rows and columns. So 3 by 3, 4 by 4, 5 by 5, so on. Okay. You're going to take your birth rates and you're going to have them go straight down. So let's say we had 5 birth rates. We're going to have those numbers going straight down. Okay. And the survival rates are going to start right next to this one and then go on a diagonal, with everything else being zeros. So because I have 5 numbers going down, I'm going to have 5 numbers going across. So here's 1, here's 2, there's 3, there's 4, and there's 5. So then the next survival rate isn't going to go directly below that. It's going to go on a diagonal. And I'm going to fill in zeros into the other spots. And then the next one will go on a diagonal and fill in zeros. And then next one out of this. So see how those go on a straight diagonal there? And then the last one, we're going to always, just again for simplicity's sake, have the last survival rate always be 0. So there's not going to be that extra, I know it's, you're saying, well, can anything live beyond that? We're just going, even though there's obviously that, usually that possibility, we're just going to say, again, to make it simplistic enough, that it's not. Okay. So you're always going to have one less survival rate than birth rate. So we've got 5 of those, 4 of those. If we had 7 of these, we would have 6 of these. Bottom number down here is always going to be 0. All right, so that's how you create those. So let's do an example here. So you've got this rat population. Let's do their initial population. I'm going to call that P sub 0 for time 0. Would be these 6 numbers. Like so. All right, then the Leslie matrix, because there's 6 numbers here, our Leslie matrix is going to end up being 6 by 6. Okay, so let's take our birth rates, have those going straight down. If you want to put 0.7, that's perfectly fine. I'm just going to put the decimal point on there. Okay, survival rates then. So the very first survival rate will go right next to your first birth rate. 6 numbers down, so 6 numbers across. So since I have 2 there, there's 3, there's 4, there's 5, there's 6. All right, next survival rate on a diagonal, so put a 0 in that spot, zeros in the rest. Next one is also 0.9, diagonal. Next one is 0.8. Next one is 0.6. And then zeros in the rest of the spot. Okay, so there's our population and Leslie matrices. All right, now we're going to take those and put them into the calculator. So if you want to read this, you can pause and take a look at that, but I'm going to actually show it here. I'm going to go back to the previous page. All right. New matrices, clear them out. All right, population matrix. Okay, that is going to be a 1 by 6. Okay, now here's how I like to type in this matrix. So this is 6 by 6. So I usually use the enter button, but in this one I'm going to use the arrows on the keypad here. So I'm going to type in 0, it's already there. And then I'm going to hit the down arrow, and I'm going to type in the 0.3, and then hit the down arrow, type in the 0.8, and so on. Because they're all the zeros are already filled in. I don't want to keep typing the zeros over those things. I only want to type in the stuff that needs to be typed in. Okay. Then I'm going to use the arrows to get up to that spot. Then do 0.6 down right, 0.9 down right, 0.9 down right, 0.8 down right. See how it had to move over so that you'd be able to see all of those. 0.6 and then down, and then that number there should be 0. Okay, so see how all the zeros were already in there? I didn't have to type them all. You can type them all if you want to, but that does waste a little bit of time. Okay, both matrices are in. Let's double check the numbers. 69986, and then over here 0, 0.3, 0.8, 0.7, 0.4, 0. Okay, so let's quit out of there. Now, if I want to find how the new population would be after 1 year, I'm going to take those two matrices and I'm going to multiply them together. So matrix A times matrix B. Okay, and there's my new population breakdown, right? So after 1 year. So if I were to take these, because you can't have 16.6 rats, you're going to take those and round them. So 17, 9, 8, 12, 4, and 0. These would be the ones that are age 0, age 1, age 2, age 3, age 4, age 5. I'm sorry. These would be 0, 1, 2, 3, 4, and 5. Okay. Now, what if I wanted to find them after another year? So what I'd want to do is I would want to take this answer and multiply it by B. So that would be doing matrix A times matrix B. And then to that, I'd want to multiply matrix B. Okay, but that, what if I want to do this for 12 years? I don't want to go B times B times B. Well, B times B is just B squared. So if I were to do matrix A times matrix B squared, there it is. And then if I would want it for 3 years, just change the 2 to 3. Or if I were to want it for 8 years, second and enter, okay, we'll pop that back up, or you can arrow up to it either way. Okay, now see how you can't see those numbers very well? See how there's this arrow right here? If you take on your arrows here and just move those over, you'll be able to see those numbers a little bit better. Okay? So that's how you come up with those. Then if a problem asks for the total, then all you have to do is just take those numbers and add them together. So that's how you do population projections with matrices. That is lesson 39. Let me know if you have any questions.